Hello everybody, welcome to the virtual planetarium for September, and as ever we're going to start with the inner solar system and work our way out. So we start with the planet Mercury, and it's an evening object during September, but the position of the planet in the sky deteriorates rather quickly as the month goes on.
Yes, it does. I think your best chance of spotting it will be on the 1st of September, when it'll be shining at Mag 0 and setting 30 minutes after the sun below the western horizon. So that doesn't give you very long to look for it, does it?
No, it's fleeting is Mercury, and it's quickly gone after it's good. So yes, not terribly good. But moving out further now to planet Venus, we have Venus in the evening skies, but of course it's been incredibly low down. I've been following the planet telescopically in the daytime because the planet gets at a reasonable altitude then. But if you're kind of hoping to catch it in the evening skies, you'll find it is really rather low down.
Yeah.
It is getting better positioned, though, at the end of the month. And it's really quite bright, shining at magnitude minus 4.0 and increasing to minus 4.2. So quite a brilliant object, but you will need a flat sort of southwestern horizon to be able to see it, I think.
Yes, that's right. And there's a waxing crescent moon joining Venus on the evening of the 9th of September. The 9% lit moon will be fairly close to it. And it'll also be there on the 10th of September, of course, but at a greater phase, 17% lit on that date.
Okay, and moving out to Mars, well, it's...
You won't see Mars.
No, it really isn't a target this month. It's far too close to the sun, shining at magnitude 1.8, so it'd be a very difficult target. It is, of course, completely the other side now of the solar system to us, so we wouldn't be able to see many details. But it won't be too many months now before Mars returns to the morning sky, and we can look forward to it, another Mars apparition.
That's right, 2022 is a good one, isn't it, for Mars?
It is. It's really very good for Northern Hemisphere observers because the planet will be much higher in the sky, although when it comes to opposition, it won't be as large as it was back in 2020.
No.
But compensation, it is much higher in the sky.
Yes, okay. Well, what about Jupiter? Jupiter's been pretty impressive, actually, this year. It reached opposition last month on the 19th of August, and it still manages to reach a reasonable, I say good, but it's good comparative to what it was last year. It gets up to about 23 degrees from the centre of the UK. So it's not too bad, is it really?
No, it's not too bad, and we've had some good seeing here from time to time, even though Jupiter is quite low down in the summer months. But we have had some good seeing, and my 12-inch telescope has been showing some phenomenal details. One of the things you notice, even in a small telescope, is that the equatorial zone of the planet now contains this really strong orange colour, and the northern equatorial belt, this is the belt, the darker belt at the bottom, is really quite a lot thinner now because it's contracted back a bit. So there's some interesting changes. And the Great Red Spot has a darker colouring around the outside, which actually makes it easier to see in smaller telescopes. And I know people who've got 4-inch telescopes have been able to see the Great Red Spot. So it's been some interesting dynamic changes. And of course, following your guide in the magazine, Pete, all the various different Galilean phenomena have been quite fascinating to watch as well.
Yes, they have. And we've had an opportunity to watch Callisto, of course, transiting across the disk of Jupiter, which is always very welcome. Okay, well, Saturn was also at opposition at the beginning of August, on the 2nd of August, so that's quite close to opposition as well. So that's pretty good for us in the UK to view, because it's now starting to get higher in the sky, isn't it? It's been so low for such a long time.
It feels like it's been down south for a lifetime, but it is now slowly creeping up. Of course, the problem is that Saturn takes about 30 years to go around the sun, so it spends a significant amount of time in each of the constellations passing through the ecliptic. That's great when it's in Taurus or Leo or whatever, but when it's in Sagittarius or Capricorn, it takes forever to climb back up. But as you say, it is slowly climbing back up now, so that's going to be good.
Well, the best placed planet currently is Uranus.
Yes,
which is
it is actually.
Well,
Out of all of them.
yes, right. Well, it reaches an altitude of 50 degrees in total darkness in the early morning sky. It's currently in Aries, the Ram, located not too far from the Pleiades, actually. It's moving further to the east and getting closer to that open cluster. So, yeah. I mean, Uranus is small and it's faint. It's on the threshold of visibility for the naked eye. But it is an interesting planet to look at. The colour's fantastic, even through a small telescope.
Yeah, it's got this very striking cyan green hue to it. And you do see belts and zones. They're nowhere near as marked or as distinctive as they are on Jupiter and Saturn. But even an 8-inch telescope will show you some interesting variations on the disk. And I'm looking forward to using my 12-inch telescope to see what I can see on it. And as well as that, you've got the Uranian moons, which orbit in a very strange way because the planet is tilted over on its axis. So they've got orbital patterns that are quite different to those of Jupiter and Saturn. So there's lots of fun stuff to do with Uranus, and it's good that it's quite high up because people like yourself who are imaging in the country have got some good shouts now of getting some interesting weather details on Uranus, because we know that the planet isn't bland and it does throw up these interesting storms.
Yes, indeed. Neptune too. Neptune comes to opposition this month on the 14th of September. But that's even further out, of course, and it has a tiny 2 arcsecond disk, which is pretty difficult to see much detail on. But you do get the lovely colour again.
You do.
And a power of 200 times will show the disk reasonably well. But it is difficult to visually make out much in the way on Neptune's disk.
Never seen anything on it. I used the university's 20-inch Cassegrain on it once, and it was still a little blue disk. So I think it is quite tough. I don't think there's much in the way of well differentiated bright zones and darker belts on it. It's certainly the outer giants, Uranus and Neptune, they don't have that really striking brighter zones and darker belts that Jupiter and Saturn do.
No.
I have seen images amateur images showing bright spots on both Uranus and Neptune. So it can be done, but it is a very difficult task, as you say, because the disk size is so small.
And it's also worth noting that Neptune's largest moon, Triton, is within range. It shines at magnitude plus 13.5, and it's an easy catch for a 12-inch scope, but it isn't out of the range of smaller telescopes as well. I would guess about 200 millimeters, an 8-inch scope is probably the minimum to see it. But that's quite remarkable, isn't it?
It is, given how far away it is and how small it is. Yes, I have seen Triton with my 8-inch telescope, so I know that's certainly possible. I've heard rumours that from dark sky sites, it can be seen with a 6-inch telescope. I haven't seen it myself, so I couldn't comment. But if you've got a really dark sky, really transparent sky, it might be the case. I suppose it depends on visual acuity of the observer and the conditions at the time.
Okay. Interesting. Okay, well, let's go on to the special events occurring this month. We start off with 2 lunar occultations of naked eye stars. On the morning of the 2nd of September, a 24% lit waning crescent moon occults magnitude plus 3 Mebsuta, which is Epsilon Geminorum, from 0112 BST until 0204 BST. Those times, by the way, are correct for the centre of the UK, and they will vary a little bit with location. And then on the morning of the 3rd, it's the turn of Mag 3.6 Kappa Geminorum that gets occulted from 0341 BST until 0438 BST. So it's a good opportunity to practice your lunar occultation observing techniques.
Yeah, those are actually good fun, and it's always interesting to time them if you can time them accurately and see how they compare to predictions. So that's actually quite a valuable thing to do.
Yeah. Okay.
On the 6th, we have an excellent opportunity to spot a less than 1% thin crescent moon in the morning. The moon is located about 5.6 degrees to the left of and fractionally down a little bit from the star Regulus, the bright star Alpha Leonis. So the moon rises 75 minutes before the sun, so it's a bit of a challenge to try and get it just as the morning light is approaching, but that should be an interesting thing to try and go for.
Absolutely, and it's quite. I have done this before in the morning sky, and it's really quite an amazing sight at this time of year because the angle of the ecliptic is pretty good to lift the moon up. In fact, I do remember this from a number of years ago because I set my telescope up in my front garden, polar aligned the mount, and then realised when it was too late, as the sky was getting brighter, that there was a hedge in the way where the moon was going to be. So at some ridiculous hour in the morning, I took out my hedge trimmers and cut a nice neat rectangle or angular bit out of the corner of the hedge, which wasn't met with too much pleasure.
No, wouldn't that have woken everybody up? But astronomy means you have to make sacrifices.
Oh, absolutely. Yes, far more important. But on the 7th, there's another excellent opportunity to spot an ultra-thin moon in the evening sky. So that's after it's passed through new moon. So you look down above the western horizon just after sunset to spot again a less than 1% illuminated waxing crescent moon. This one is harder though because the ecliptic angle is shallower. The moon sets approximately 35 minutes after the sun. That's going to be really tricky.
Yeah, you've got to get your skates on with that. That is going to be tough. On the 9th of September, if you look above the west-southwest horizon, shortly after sunset, you'll see a 9% lit waxing crescent moon and the brilliant planet Venus, magnitude -4, together with the star Spica in Virgo. So that's a nice little grouping of objects, each of them different, that you might want to have a look out for.
And on the 13th, a telescopic view of the first quarter moon around 21:30 BST will reveal those popular clair-obscur effects known as the lunar X and V, the two giant letters which appear on the moon's terminator. And it's worth noting that the equivalent, or the morning equivalent to the first quarter moon, that will be the last quarter moon on the 29th of September, will give you an opportunity to see another clair-obscur effect, which is known as Grithuson's lunar city, which is quite close to the 10-kilometre diameter crater Schroter W. And that's an effect named after Franz von Paula Grithuysen, who thought it was a populated city on the moon.
Under the lighting, though, it does kind of look city-esque at times.
Well, there is a sort of fan shape to it with a load of linear features which make it look as if they're streets.
Yes. It's actually, have you noticed, it's actually an effect that only works in smaller telescopes.
Yes.
If you use a larger telescope, then there's so much fine detail you can see it's nothing of the sort. There's nothing artificial about it at all. But in a smaller telescope, it does look quite artificial.
That happens with a lot of clair-obscur effects, actually. Once you look at them through a big telescope, the effect is ruined because you're seeing too much detail, which is quite interesting. Okay, well, on the evening of the 17th, there's an interesting arrangement in the south at 22:30 with an 89% lit waxing gibbous moon located between and south of Mag plus 0.6 Saturn and minus 2.6 Jupiter. And if you look at Jupiter with a telescope, there's a fantastic opportunity to watch Callisto's shadow transit across the disk of Jupiter, starting at 23:43 BST, with Jupiter setting just before the transit ends at 04:12 BST.
That's quite good, because I love Callisto transits, because they're so rare to catch them, because Callisto orbits Jupiter much further out. It takes longer to go around. And if you combine that with the fact that you only get these kind of transits with Callisto on the disk when, we're at this particular point of Jupiter's orbit, and a clear night, it actually becomes quite a challenge to capture them.
Yes, it does. Well, there are a couple of other events, one involving the moon and one connected to the moon a little bit. Let's do that one first. On the 22nd, we have the Northern Hemisphere's autumn equinox, or the September equinox, if we want to be fair to the Southern Hemisphere. This is where the sun's disk, or the centre of the sun's disk, crosses the celestial equator, moving from the northern part of the sky to the southern part of the sky. And the full moon on the 20th of September is the closest full moon to that equinox, which makes it the harvest moon for 2021.
Ah, there we go.
Okay, well, let's now head out to the stars. So we have a good darkening to the sky in September because that equinox gives us the fastest rate of increase of nighttime darkness for the entire year. So the night is getting longer at its fastest rate in September. And that allows us to see some fantastic stars. The stars of summer are still there. We've got the huge asterism known as the Summer Triangle, positioned close to the meridian, that's the north-south line in the sky, as the sky starts to get truly dark. And that's a beautiful part of the sky, isn't it?
It is, and actually, even though we call it the Summer Triangle, it's around for a long period of time.
You can see most of it in December, can't you?
You can, yeah. But it's at its best in the summer months. And it's marked by the three brilliant stars. We have Deneb in the upper left, the brightest star in Cygnus. We have Vega in the upper right, the brightest star in Lyra the Lyre. And then finally down at the bottom part of the triangle, we have Altair in Aquila. And Vega sits above a small but very distinctive little diamond shape of stars.
Yeah.
It does look a little bit like an old-fashioned lyra, this harp-like musical instrument. And there's some interesting stuff that is very within very easy reach of small telescopes here. And that's in particular the Ring Nebula, M57, which lies almost between the two bottom stars of Beta and Gamma Lyrae. And if you just scan around there, you'll see this little faint patch of light, which in small telescopes actually you can see the oval structure quite clearly. I've seen that with a 4-inch telescope many times.
But you have to be aware that the M57 actually sits slightly below that line, joining those two stars together.
Yes.
And it's offset towards the star at the west, which I think from memory is Beta, isn't it?
I think so, yes.
Yeah. So basically, if you need a reasonable power as well to see it, because if you look at it with a low power, you'll see a tiny dot which you might mistake for a star. So you have to sort of look for what you think is M57 and then pile the power on and see if you can see this beautiful planetary nebula. Well, if we move to Cygnus, that represents a giant swan nosediving, or should we say swan diving, towards the horizon. And the main body and beginnings of the bird's wings are picked out by a well-known asterism known as the Northern Cross.
And it does look like a cross, and it's in the north, so it's a reasonable asterism. Yeah, and at the foot of the cross, we've got the beautiful telescopic double star, Albiro, which is really quite a beautiful double star system. We've got the brightest star, which is this orange red giant, and nearby this turquoise blue star. I do often wonder whether the turquoise blue star looks more turquoise because it's the contrast with the nearby orange giant, but it's certainly quite a striking sight and very easy to find. And below that, we've got this rather obscure constellation of Vulpecula the Fox, which isn't well defined to the naked eye, but it does contain a couple of really nice objects, perhaps the most famous one being M27, the Dumble Nebula, which is like M57. It's a class of nebula we call the planetary nebulae. These are nebulae that have formed because the stars that they were originally there shed off the outer atmosphere, and so they're the remnants of these stars. And one day our own sun will become a planetary nebula in somebody's sky, but not for many billions of years in the future.
No, an M27, it has to be said, is a fantastic planetary nebula. It's very large and it's bright. You can see it with binoculars reasonably easily. Small telescope will show its shape to be round with two bits cut out either side. So it looks a bit like an apple core, I suppose, the best way to describe it.
It does, and as you say, just like with M57, if you can pile on the magnification here, and it doesn't matter too much if the seeing isn't great. It's the great thing about deep sky objects is you can still use higher powers even if the seeing's a bit wobbly. What you do need more is transparent, very clear skies in order to use high power, otherwise the brightness becomes too dim. That becomes a bit of an issue, I find.
Yeah, okay. Well, 8 degrees due south of Albireo and close to the flight stars of Sagitta the Arrow lies it's a lovely little cluster. You can see it with the naked eye. It's called Brocchi's cluster.
Yes.
Colander 399. It's also known as the coat hanger because strangely, it looks exactly like a coat hanger in the sky. And even though it's called a cluster, it's not. It's an asterism, a chance alignment of stars.
Yeah, and it's quite a distinctive one, actually. So definitely one to watch out for. Hanging to the south of the star Epsilon Cygni is a fourth magnitude star, which is known as 52 Cygni. And this is a marker for the rather fantastic object, the Veil Nebula. And this is the supernova remnants, a star that blew itself apart. So unlike the planetary nebulae, which are formed by stars the same sort of size as the sun and blow off their outer atmospheres, the Veil Nebula is a result of a star blowing itself up. And I have to say, it can be seen easily with a wide field eyepiece, but imaging brings it out, the details much better.
Yes, it does. It does. Okay. Well, we've got the eastern wing tip of Cygnus bridges the gap between summer and autumn because it stretches across towards Pegasus, the flying horse, which is a defining signpost constellation of autumn. The horse is shown upside down for those of us living in the UK, with the constellation stars marking his upper torso, forelegs and head. The main pattern of Pegasus is known as the Great Square of Pegasus, and once found is very easy to recognise, although it does look rather empty. It's like a void in the sky, isn't it?
It is, and actually you can use the square Pegasus to see how dark your sky is, because if you look closely, and once you need to be dark adapted for this, so wait till you've been outside for 15 minutes before trying it, but if you count the number of stars you can see inside the square Pegasus, if you're at a very good dark sky site, you'll see quite a few. If you've, sort of looking from the centre of London, you may only see one or two. So it's a good little test to see how dark your site is that you're observing from.
Well, if you extend the eastern side of the Great Square of Pegasus down, you locate a bright star called Deneb Katos, or Difta, which is Beta Ceti. And 7.3 degrees south and a fraction east of that star lies NGC 253, which is the Sculptor Galaxy. And have you ever seen that?
No. No, I haven't. It's too low down for my horizon, I think.
Well, just knock a house down or something. But at magnitude plus 7.1, it's quite bright, and it's a real treat. It's a fantastic galaxy. It really is good. A lot of people dismiss it because, like you've just said, it's very low down. But if you can get a view towards the south when it's at culminating, so it's at its highest point due south, it's really well worth the chase. It surprised me when I managed to get it.
Okay, I'll have to work out when it's going to be between the houses, I think, but I've been doing that for Saturn and Jupiter for the last however many years, so I'll give that a go. I'll put some effort in, Pete.
Okay, well, if we'll end with extending the other side of the Great Square of Pegasus. So that's the right-hand or western side of the Great Square down towards the horizon. And there you'll find a really bright star, which we always argue about the pronunciation of this star. I call it Fomalhaut, but you call it Fomalhaut.
I do call it Fomalhaut because
You're probably right.
I don't believe the T is silent. So, but there we are.
I think you're probably right, actually. But that's the brightest, or it's the lowest first magnitude star you can see from the UK. And if you have any obstructions on your horizon, you won't see it. So as ever, there's lots and lots to see in the night sky, and we wish you clear skies to go out and see them all.
Absolutely. Thanks, Pete.
Thanks, Paul.